Good evening, students. Welcome back. So we have set to solve the problems which are given in the question bank provided by Bangalore North University Physics Department. So the question is like this. The distance between two coherent sources of light is 0.16 millimeters. Interference fringes are observed on a screen placed at a distance of 1.2 meters from the sources. It is found that with a certain monochromatic source of light, the second bright fringe is at a distance of 9.6 millimeters from the central fringe. What is the wavelength of the source? Okay, so as you can see, the question is related to interference of light. So what's interference? Let's learn that first. What happens is, let's say there is a source of light somewhere over here and we have kept a double slit in front of it. What's a double slit? It is just like any kind of barrier which has two slits in that, okay, which are at a distance of small d. The light passes through those two slits, and when a screen is kept at a distance of x distance from the source or from the slit, it forms a pattern given here. The pattern looks somewhat like, in the center there is a bright fringe. As we go away from the central fringe, the intensity of the light also decreases, as well as the width of the thickness of the fringes also will decrease. Right? Now, if we try to draw a graph of that, the graph looks like here. When I say central bright fringe, I mean this. When I say first bright fringe, I would mean either this or this. Okay. When I say second bright fringe, I mean this and this. So it is like central bright fringe, first order, second order, third order, fourth order, just like that. Okay, on either side of the center. Now, the distance of the first bright fringe is given as y1, meaning the distance between the center and the first bright fringe is y1. The distance between the center and the second bright fringe, let's take that as y2. Next is, the pictorial representation looks somewhat like this. Let's say there is a point P which is at a distance of y from the central bright fringe. Now, just as I said, the distance of the first bright fringe is y1, second bright fringe is y2. Let's say mth bright fringe is at this point. Okay, point P. Then the distance is named as ym. Formula for that ym can be ym equals lambda m capital D divided by small d, where ym is the distance of the mth bright fringe, lambda is the wavelength of the light used, m is the order, d is the distance from the source and the screen, and small d is the slit width. That is, what is the distance between two slits. Right? Now, what is the question here? What is given in the question is, let's write the data. So, there are two coherent sources of light which are at a distance of, that is small d, that is the slit width is given 0.16 mm, which can be written as 0.16 into 10 to the power of minus 3 meters. The screen is at a distance of 1.2 meters. You should observe here that the light uses monochromatic source. The second bright fringe is at a distance of 9.6 mm. How do I write second bright fringe? y2. It is equal to 9.6 mm, which is 9.6 into 10 to the power of minus 3 meters. What is the wavelength of the source? Lambda is question. What's the formula? We have already learned the formula, right? Ym equals m lambda d divided by small. What are we supposed to find out? We are supposed to find out lambda. So let's derive expression for lambda rather than ym. That is, lambda equals ym d divided by m capital D. What is ym here? Since we are finding out lambda for we know the value of y2, that is for the second bright fringe. Obviously, in this statement, the value of m is written, which is m is equal to 2. We can write it as y2d divided by md. What is y2 now? 9.6 into 10 to the power of minus 3 times Small d value is 0.16 into 10 to the power of minus 3 divided by value of m is 2, d is 1.2. So we have lambda is equal to, when we calculate all these things, we get 0.64 into 10 to the power of minus 6, or we can write it as 6.4 into 10 to the power of minus 7 meters. Suppose I want to write it in terms of angstrom, I can write it as 6400 into 10 to the power of minus 10 meters. So this is the value of lambda. Please make sure, students, you are supposed to write the exact answer as well as the unit. Unit carries 1 mark.